Hello there. The purpose of the following video is to show you how to calculate a between groups ANOVA to show you how to calculate a between groups ANOVA in Excel. So just like all our other videos, make sure you have your Excel spreadsheet open and the directions in the Word document available so you can follow along and replicate what I do. You're always welcome to pause the video at any time to perform calculations or to catch up. Now, always the first step that we want to do is want to make sure that when we open the spreadsheet, that we check the code book and make sure that we understand the variable that's being collected as well as the research question. So if you have your spreadsheet open, let's go ahead and go down to that code book tab and let's read the scenario really quick and then we'll look at our different variables here. So in this case, let's assume in this scenario that decisions about long-term care for elderly populations affect most families as relatives age. So suppose you're interested in knowing the factors that may predict whether a person chooses to care for a parent once they are no longer able to care for themselves. So you suspect that a person's general outlook on life, positivity, is one of those factors. You decide to ask college students two questions. One question asks about their outlook on life as either being a negative outlook, a neutral outlook, or a positive outlook. Note that this is your independent variable. The other question asks about their likelihood of caring for their parents when their parents are no longer able to care for themselves. And that's going to be our dependent variable. So we're going to use the data in the Excel spreadsheet to investigate the research question. It looks like in this case we're going to use an alpha of 0.01 to test this hypothesis. Okay, so now that we know the scenario here, let's take a look at our particular variables. So on the data page, I'm just going to switch back really quick. On the data page, you're going to notice that we have three columns of data here. One says neg out, for in other words, negative outcome, or outlook, I'm sorry. And then another one is a neutral outlook, and then the other one is a positive outlook. So new out and pause out. If we hover over those, we see that it looks like it's a 1 to 7 scale here. So it's a response scale from very unlikely to very likely. Obviously, that's important when it comes to our assumptions. If we look at the code book, you can see exactly what's being asked of these individuals. So how likely are you to care, again, physically, financially, and emotionally for your parents when they're no longer able to care for themselves when you have a negative outlook on life? So there's your level of your independent variable. The next one is very similar, right? The new out. In this case, it's a neutral outlook on life, but we're still asking about how likely they are to care for their parents. And the last one is a positive outlook on life, and again, likelihood of caring for one's parents. And so each of our participants is going to fall into one of these three groups because each person either has a positive outlook, a neutral outlook, or a negative outlook. So they don't have all those outlooks simultaneously, so they're only being measured once and only once in one of these levels of the independent variable. That's what makes this a between groups ANOVA or between groups design. And again, of course, they're all being measured on this 7-point scale from very unlikely to very likely. All right, so let's go back to our data here. There's no other data cleaning that we need to do. If we had some blank cells, that's fine. The between groups ANOVA would handle that. Do note that we have unequal sample sizes, and it's perfectly fine with the between groups ANOVA because each of these groups are independent of each other. We're not measuring the same observations multiple times. Right, and so we can have unequal sample sizes, and that's perfectly fine. Now, don't forget to check your data tab and make sure that you have your data analysis tool pack installed. So that way, when you get to that point of this tutorial, this video, you'll be able to follow along with the data analysis. All right, so if you've already opened up your step-by-step document, you can go ahead and take a look at it. If you haven't, go ahead and open that up. Pause the video and open it up. So you're going to see several steps here. The very first step has been the same as it's been for many of these videos. We're going to go ahead and get our descriptive statistics for each level of that independent variable. So in other words, for these three columns of data. And step two, we're going to go ahead and get that ANOVA single factor to get our between groups ANOVA output. So let's start with our descriptive statistics, and then we'll get the output for the ANOVA. So you know how to get descriptive statistics already. Just go ahead and go to data analysis. Descriptive statistics, click OK. And again, you can collect all of them at the same time. So we're just going to highlight those three columns. We're going to make sure we have our labels in the first row checked. We want our summary statistics. We're going to put our output someplace. I'm going to give myself just a little bit of room from the data, and I'm going to click OK. And so notice that in our descriptive statistics, we have all of our levels of the independent variable. So likelihood of caring for one's parents when they have a negative outlook on life, likelihood of caring for one's parents when they have a neutral outlook on life, and then the likelihood of caring for one's parents when there's a positive outlook on life. And those are our three groups that we're going to be comparing to each other. If you look at the counts, you see that we have unequal sample sizes, but we kind of knew that already, so that's not particularly new. But just note in this case, right, we have 18 in one, 28 in the other, and 17 in the last one. We want to report our means and standard deviations, so we'll make sure that we'll just mark where those are here in our output. And as always, be mindful that you get your standard deviations and not accidentally grab your standard errors when reporting that when it comes to an assignment or an exam. All right, so let's go ahead. We got our descriptive statistics here. Let's go ahead and get our ANOVA output. So this is going to be step 2 in that Word document. And so you see here that we're just going to go data analysis. We're going to click on ANOVA. There's several ANOVAs in the drop-down menu. We want the one that says single factor. We'll click OK. We'll highlight our data and labels. We'll just make sure that it's being grouped by columns. We'll check the labels in the first row box, verify our alpha level, which we said in this case was 0.01, and then we'll place our output someplace on our spreadsheet. So let's walk through that. Data tab, data analysis. At the very top here, we have 3 ANOVAs. The one that we want here is this ANOVA single factor. Remember, this is a one-way between groups ANOVA. There's only one factor or one independent variable. All right, so that's the one that we are going to choose. We'll click OK. We'll highlight our 3 columns of data. We'll make sure that it's being grouped by columns, which it is. We'll check on our labels in the first row. We will adjust our alpha because we're going to use an alpha of 0.01 here, not 0.05. Remember, we saw that in this scenario. And then we're going to place our output in our spreadsheet. And I'm just going to place it right below our descriptive statistics. You can place it elsewhere if you like, but I'm going to put it right below our descriptive statistics. And click OK. And we're going to get our ANOVA output. So you're going to see a few things here. You're going to see some summary statistics. You'll note that the averages are exactly the same that you got here in your descriptive statistics right above it. Our counts are going to be the same as well, so 18, 28, and 17. We do get the variance of each group. Now, you'll notice that variance matches what's in our descriptive statistics here, but what we want to get is our standard deviations, and that's why we got the descriptive statistics first, because it gives us those standard deviations. Now, if you know that the standard deviation is just the square root of the variance, you could create another column over here and calculate those standard deviations and then not even bother with the descriptive statistics. I won't do that here, but if you want to do that shortcut, that's perfectly fine as well when it comes to an assignment or an exam. The last thing you're going to notice here is an ANOVA source table. And so if you've read the lecture, you know that the source table is important for getting some of the information that we need for, let's say, the effect size or the harmonic mean. So we'll definitely come back and do some calculations out of this particular table. Now what we're particularly interested in here is going to be the F statistic, and then also the F critical value. So remember that our F distribution is a positively skewed distribution, that these values are always going to be positive values. The F critical value is just like any other statistical test. If we exceed that critical value, then we are going to reject the null hypothesis. If our value is between 0 and that critical value, in other words, it's less than that critical value, then we're going to fail to reject the null. So the larger the F statistic is, the more rare that value is, and the less likely it is to occur by chance. So if we're looking at our 2 values here for that F critical and that F statistic, you'll notice that our F critical is 4.98. The F statistic is 13.55, which exceeds the critical value. It's larger than a critical value. So in this case, we are going to reject the null hypothesis, which means it appears that there is at least, remember we're going to say that wording, at least here, because there's multiple comparisons. We have negative outlook versus neutral outlook. We got negative outlook versus positive outlook. We got neutral versus positive. All right, so it appears at least one difference in likelihood to care for one's parents depending on a person's outlook on life. Now we don't know where, right? We don't know if it's between negative and neutral or positive and negative, or maybe it's through two of the three, right? There could be multiple. So we don't know here based on this, but we do know just overall with our F-test, with the omnibus test, is that there's at least one difference among those groups. So we reject the null hypothesis. So just like before, your F statistic, if it exceeds your F critical, you're going to reject the null hypothesis. Now you remember from the lecture that if you reject the null hypothesis, you can try to determine which groups are different from each other by doing post-hoc tests, by doing a Tukey's post-hoc test. So we're going to do some post-hoc tests here. Now remember, if you fail to reject the null, then there's no reason to do post-hoc tests, right? If you say there's no differences among the groups, there's no reason to do post-hoc tests to find where those no differences are. It doesn't make any sense. And so in this case, we're going to do some post-hoc tests. We're going to need to get Q statistics for each of our comparisons. So that means we need to get our comparisons up here first. So let's look at our comparisons. Here we have 3 levels of the independent variable. So that means we're going to have 3 comparisons. And again, I'm just using our formula that we learned in the lecture, k times k minus 1 divided by 2. So if I have 3 levels or 3 groups, I multiply that by 2, which is k minus 1, so 3 times 2 is 6, divided by 2 gives me 3 comparisons. And those comparisons are going to be negative versus neutral, negative versus positive outlook, and neutral versus a positive outlook. And so each of those we're going to calculate a Q statistic that we will then compare to a Q critical value. So we'll get a critical value here at the end, but I'm just going to make a space for it, Q crit, for the Q critical value. To get that Q statistic, remember we need to calculate the standard error pooled. And to get that standard error pooled, right, we need to calculate a harmonic mean. And those formulas are in the step-by-step guide in that Word document. So notice right now we're getting our post-hoc tests. So the first thing that we'll need to do, if we're looking at this, we need to look at our formula for the harmonic mean. We'll need to get that harmonic mean. We'll put that harmonic mean into our formula for the standard error pooled. And then we're going to put that standard error into our Q statistics in the denominator here. And then we'll subtract the means of the 2 groups that we look at for each of those comparisons. Okay, so let's start with that harmonic mean. For the harmonic mean, we are going to get the number of groups, or the number of levels, which is k. We're going to divide by 1 over the sample size of each of those groups. So remember your symbols, that n equals the sample size of each individual group. So here X, Y, and Z. So sample size for negative outlook, sample size for positive outlook, and then sample size for a neutral outlook. So let's start there. So we're going to do our formula here. We're going to hit equals. We have 3 groups. I'm going to hit 3. We're going to divide by 1 over the sample size of each of the groups added together. And so we will need to put this in parentheses. So we'll do open parentheses and we'll go 1 divided by, and I'm just going to click on the count for one of the groups. I'll hit my plus sign, go 1 divided by the count for the next group, plus sign, 1 divided by the count for the third group. I'll go ahead and close my parentheses and then hit enter. And that's going to give me a harmonic mean of 19.99. Now remember that the harmonic mean is a weighted average of the sample sizes. So this value should fall somewhere between your lowest count and your highest count. So in this case, our lowest is 17, our highest is 28. We would expect that this harmonic mean is going to fall someplace in between, which it does, right, around 19.98. Okay, so very good. So once we have the harmonic mean, we need to go ahead and get our standard error. The formula for the standard error is going to be the mean squared within from the source table, then divided by that harmonic mean that we just calculated, and then we take the square root of that ratio. So let's do our calculation here. So for our standard error, we're going to hit equals. We are going to do an open parentheses here. We're going to take the mean squared within in our source table. So notice we have within groups right here. You see the mean squared, so it's going to be this value right here. And we're going to take that mean squared within, and we're going to divide by that harmonic mean that we just calculated. We will close our parentheses, and we'll need to take a square root. So we'll do our shift 6, which gives us the up arrow, and then our square root value is 0.5. Once we do that, we'll hit enter. Now it looks like our standard error pooled in this case is going to be 0.23. Once we have that standard error pooled value, we can then calculate our Q statistic for each of our 3 comparisons. That formula for the Q statistic is the means of the 2 groups that are being compared divided by that pooled standard error. All right, so for our very first one, we're going to look at the negative outlook versus the neutral outlook. So again, how likely are you to care for your parents if you have a negative outlook versus a neutral outlook? So we're going to hit equals here. We'll do our open parentheses. We're going to take the average or the mean for the negative outlook. In this case, it looks like that value is 5.17. We're going to subtract the average for the neutral outlook. Looks like it's 6.68. We're then going to divide by that standard error pool that we just calculated, the 0.225 value. And we'll hit enter here. And it looks like we're going to get negative 6.71. Don't worry, a negative value is just fine. The Q distribution looks just like the T distribution, has negative values and positive values. It's a normal bell-shaped distribution. That's symmetrical, and so you can have negative values, and that's perfectly fine. All that negative value is telling you is that one of the groups has a lower value than the other. In this case, if we look at the means, we'll see that the likelihood of care for one's parents is lower than that of when they have a negative outlook on life than when a person has a neutral outlook on life. And so because we're taking 5.17 minus 6.68, we're going to get a negative value there. It's just saying that one is less than the other. In this case, negative outlook on life is less than the neutral outlook on life. Okay, so that's our first Q statistic. Let's get our second one. So we're going to hit equals here. We will open parentheses. And in this case, we're now going to take the negative outlook average. We're now going to subtract the positive outlook average. We'll close our parentheses and again divide by that standard error pooled, and we'll hit enter. And it looks like we're going to get negative 6.05. Again, negative again because the negative outlook on life had a lower average than the positive outlook of life when it came to the likelihood of caring for one's parents. All right, so that's 2 of our Q statistics. We got 1 left, so let's hit equals. We'll do our open parentheses again, except now we're going to compare neutral. So I'll get the mean for neutral, and I'll subtract the mean for the positive outlook. Close the parentheses, and again we're going to divide by that standard error pooled. And I'll hit enter. It looks like we get a value of 0.66. So that's great. So we have our Q statistic for each of the comparisons. Unfortunately, that doesn't tell us a whole lot until we get that critical value, right? Because we have to compare it to something. So we get this test statistic, the Q statistic. We want to know, does it exceed the critical values? And so our Q test is always a two-tailed test. So we're going to have a positive and a negative critical value. And to find that value, we have to go to the Q table. In that Q table, we need to know 3 things. We need to know the number of levels, in other words, groups that we're comparing. So here we have neutral, negative, and positive outlooks. We're going to have 3. That's our number of treatment levels. So we're looking at the 3 column here. We also need to know our degrees of freedom within, and we need to know our significance level. The significance level is just the alpha. So we know alpha is 0.01. We know that we have 3 levels to our independent variable, or 3 groups. So the only thing we need to find here is the within groups degrees of freedom. Luckily, that is going to be in our output. So we can go ahead and take a look at the source table in Excel. You're going to see here within groups, and you're going to see DF for degrees of freedom. So it looks like in this case, our degrees of freedom within is going to be 60. So we can now use all of that information to go ahead and calculate that Q critical value. And so we're looking at the 3 column. We'll go down to a degrees of freedom of 60. If there isn't one for 60, we go to the one that is closest to. It looks like here we do have a value for 60, so we don't need to round one way or the other. And we're going to use our alpha 0.01. So it looks like I get a value of 4.28. The Q critical value is always two-tailed, so this is going to be a positive and negative 4.28. Now that we have that Q critical value, let's go ahead and go back to our spreadsheet here. Our critical value is a positive and negative 4.28. So let's go ahead and put that in here in our spreadsheet. So we're going to compare each of those Q statistics to the Q critical value, just like we did with the F statistic and the F critical value, just like we've done in the past with the T statistic and the T critical value. Right? If our statistic exceeds in either direction, right, the critical value, then we're going to reject the null hypothesis. So let's take a look here. Let's look at our very first comparison. We have negative versus neutral. So again, the likelihood of caring for one's parents in their old age. Depending on if you have a negative outlook versus a neutral outlook. Our Q statistic is negative 6.71, which does exceed our negative value of 4.28. It's more extreme. So again, the larger or more extreme the value is, right, the more rare it is, the less likely that there's a difference because of chance. So in this case, it looks like we're going to reject our null hypothesis. And when I'm looking at this, it looks like, again, because we have a negative value here, looks like a negative outlook is less likely than a neutral outlook on life to care for one's parents. Again, I got that because I have a negative value here. If I go to my means, that negative tells me one is less than the other, and it looks like the negative is less than the neutral. All right, let's go to our next Q statistic. Our next Q statistic is a negative 6.05. Again, compared to our critical values, that does exceed our negative 4.28. So again, we are going to reject the null hypothesis. We're going to say a negative outlook is less likely to care for their parents than a positive outlook on life. All right, so only one more comparison. Our Q statistic for neutral versus positive is 0.66. That does not exceed our critical values. It's not greater than 4.28. So we're going to fail to reject the null hypothesis. It appears like there is no difference between neutral and our positive outlook on life when it comes to caring for one's parents. All right, so overall with the hypothesis test, again, with that F-test, we found that there is at least one difference among our groups. We do our post-hoc test. We see in this case that there are actually 2 differences. It looks like those have a negative outlook are less likely to care for their parents than a neutral outlook. And then also those with a negative outlook in life are less likely to care for their parents than those with a positive outlook on life. All right, and that would be our overall conclusion when it comes to the hypothesis test. If we were to use this in a practical decision, we would include both the our statistical decision for the F-test as well as the Q-test, and that would be one evidence in a practical decision. Okay, so let's go down. We still need to get an effect size, right? Because this is all at the group level. Collectively, what would we expect? Collectively, it looks like those with negative outlooks on life is going to have a less likelihood to care for one's parents, and let's say neutral or positive. But what we really want to know is, does this also impact the individual person? So Tom or Susie or Jill, right? Are they going to be less likely to care for their parents if they have a negative outlook on life? All right, so that means we need to calculate an effect size. Now remember, our effect size is r squared. So if you're looking at your step-by-step guide, we'll go up here to the effect size, and you'll notice that that r squared value, called the coefficient of determination, is the sum of squares between divided by the sum of squares total. And you're going to find those two values in your source table. So if you look at your source table here, you have sources of variation, we have between groups and within groups. We have this SS, which is the sum of squares. So it looks like our between group sum of squares is 27.48. And then our sum of squares for the total is 88.32. So in other words, the squared deviations or variances for the total amount of values in our data set is 88.32. All right, so we're just going to take this 27.48 and we're going to divide by 88.32, and that's going to give us the size of the effect. So I'm going to hit equals. I'll click on my cell for the sum of squares between 27.48. I'll do my forward slash and divide by 88.32. I'll hit enter. Looks like I'm going to get 0.31 for the effect size. Now remember, what we consider to be small, moderate, and large effects now change because we're using squared values. So if we look at those rules of thumb, a large effect is around 0.14. Obviously this is exceeding that large effect. So it looks like very much that we have a large effect here at the individual level. All right, so let's just write that out just really quick here for an interpretation. In this particular case, we can say it appears that 31%, so remember to turn that decimal to a percent, just like we did in the lecture, it appears that 31% of the variability, or differences, right, variability, in people's likelihood to care for parents can be accounted for by their outlook on life, right? Whether it is negative, neutral, or positive. All right, and we're going to say that this is a large effect. All right, so just remember, you need 5 things and that explanation for the effect size. You include the percent of variability accounted for. You need to include who or what, in this case, people in general. You include the dependent variable, which is likelihood to care for one's parents. You include the independent variable, which is outlook on life. And don't forget the size of the effect. If you include all 5 of those things, then you'll get full credit when it comes to your explanation for the effect size. All right, so that does it for a between groups ANOVA from start to finish with post hoc tests and effect size. I wish you well. Make sure you practice. Make sure also that you complete this spreadsheet and then upload it to the assignment so you get full credit.